Okay, we're trying to figure out the inductance of the small loop, or a small coil, and we're making approximations. But bottom line is we observe the magnetic field and the current. The observations that I'm given, not everybody has good observations there, because one of the voltage probes was measuring oxygen level, according to the interface. But you want to find B as a multiple of I. So if you just take an observed B and divide by current I, you get what multiple that is, right? And that can be summarized by B is, well, you just divide your observed field by your observed current and multiply that by I. Okay? Now there's a big question mark here, because I don't believe that you got 5.5 amps out of just out of a bare battery. I don't think you get that many amps out of 1.5 volt battery. Okay? But you use a D cell, maybe the resistance, the internal resistance is somewhat lower than I think it is. Could be. Could be. So it's not inconceivable that you got half an amp. Okay? So you got something like 4 times 10 to the negative 4th Tesla, which is reasonable. Okay? Divided by the 0.5 amps, which is not far from reasonable, even if it isn't quite right. Okay?
All right.
Although I would think that through the resistance of that whole coil and everything else, you wouldn't get much more than 1/10 of an amp. Okay, anyhow, if you divide that, you get what? 8 times 10 to the negative 4th. Henry. Well, Tesla per amp times I, right? Okay. So
Because then you have all the information you need to basically know everything.
dB dt is this multiple of di dt.
Yeah.
Okay? And EMF,
Where?
well, then you got flux. Okay? Magnetic flux. Well,
Just 223.
I'll say area total.
So he's off.
Times dB dt, right? The flux is your magnetic field times your total area. So what's the total area? You have the data. Okay? And you have sufficient data to figure out how many loops you have.
Right.
Okay?
Yeah, we know our total number of loops in the area.
Yeah, your total number of loops is around 100, right?
I got about 153.
Yeah, well, I mean ballpark 100, okay? Just getting a ballpark number.
Right.
Okay, so you have 100 loops. Each loop has an area of a few square centimeters, right? Okay? And a square centimeter is a 10,000th of a square meter, right? So we can get a pretty good idea of, well, total area, right? And of course, that's the total area times this times di dt, right? So that equals this. So now we have the magnitude of the EMF is a multiple of the magnitude of di dt, right? Okay? That's actually negative, almost. You're not worried about the sign. So all I gotta do is have the total area, and then you've got this as a multiple of this, right? And this is your inductance.
You have to talk to.
Because that's what inductance is. It's a multiple of di dt that, of di dt that gives you your EMF. Your EMF is your d phi dt.
Right.
Okay? So, what's your total area? What's your EMF? Sorry, what's your inductance?